resistors in series and parallel. Okay, that's what we're going to cover, and we'll work some problems out. So let's first take a review. We have Ohm's Law. And what Ohm's Law says is that the resistance of a circuit or an element within a circuit is equal to the voltage it takes to get current to flow through it. That's basically Ohm's Law. Usually you'll see it as V equals IR, but I like to define it this way. Hey, what's the resistance of a circuit? The resistance is the voltage I need per amp, the voltage I need per amp of current to flow through it. And it kind of defines what an ohm is. It's a volt per amp is an ohm. And so, and we did this for very simple circuits. So we said, if, just as an example problem, if this was 12 volts, and you hooked, and let's say you measure it with a current probe, and you say, oh, the current going through here is 2.0 amps. You have a 12-volt battery, and there's 2 amps flowing through it. Well, what's the resistance of that circuit? We said, well, the resistance is just going to be equal to that 12 volts. Okay, delivered to the load resistance here, divided by the current flowing through it. And of course, 12 divided by 2 is 6. And a volt per amp is an ohm. So basically, the saying is that this circuit, whatever the resistance is in here, requires 6 volts of voltage to get 1 amp of current to flow through it. It's kind of a ratio of voltage to current. Okay. Now, and of course you can change the problem. You know, I can give you the voltage and current, and you find the resistance. That was just what we did. But I could give you the voltage and the resistance, and you have to find the current. You know, or I give you the current and the resistance. You have to figure out what the voltage is. Okay. So, pretty easy. Well, now let's take a look at more resistors, just like what we did in the lab. If I supply a voltage here, and then I have 2 resistors in series. First of all, what do we mean when resistors are in series? If resistors are in series, there's only one path for the current. So if the current is going to flow through this circuit, it's going to get here, and it's going to flow through both of them. So I'm going to call this R1 and this R2. And that's how I distinguish between resistors, is I put a little subscript next to the R. R1 refers to this resistance, R2. Now, here's what we can say. Look. Whoops. No, that's not what I want. Oh, no, that is. We know that I1 is equal to I2. Does that make sense to you, what I just wrote there as a little mathematical expression? What this means is, look, the current that flows through the first resistor is also the same current that flows through the second resistor. The two currents are equal to each other. They're in the same path. Does that make sense? Okay. Now, but here's one thing that you should know, is that by now is that that if I gain voltage from the battery, that has to be equal to the voltage drops have to be equal to the voltage gain. Okay, I've got this battery here is boosting the voltage, the energy contained in the electricity, and because of conservation of energy, that energy boost has to be equal to the energy drops on the resistor. So, in other words, the total voltage, and I'm going to call this V sub T, the total voltage delivered to the circuit by the batteries, well, that voltage gain has to be equal to the voltage drops across the resistor. So, for example, if this was like 6 volts, maybe if this was 4 volts, see if you go 6 volts up, if this was 4 volts, you would know that R2 would have to be 2 volts, right? Because you're going to need 4 plus 2 to equal the 6. The voltage gains have to equal the voltage drops in a circuit. So I'm going to use V1 and V2. What does V1 and V2 represent? The voltage drop across the first resistor, and this represents the voltage that drops across the second resistor. Okay, well, now what we're going to do is I'm going to multiply both sides of this equation by the current. Why? Well, because, see, we say V equals IR, and, oh, no, that's not what I'm going to do. I'm going to, we know that, whoops. We know that voltage, due to Ohm's law, equals current times resistance. This applies to the whole circuit, and it also applies to each individual resistor. So, I'm going to say the total voltage is going to be equal to the total current times the total resistance. Okay. Now, what is V1 equal to? Well, V1 is equal to the current through this first resistor times R1. So V1 equals I1 times R1 plus, so this is the voltage drop across the first resistor, and then this will be the voltage drop across the second resistor, is I2 times R2. Well, what do we know is true about the total current and the current through 1 and the current through 2? Because this is just one loop, all those currents are the same current. In other words, I1 equals I2, but that's also the current that's being delivered by the battery. That's the total current to the circuit. So in other words, this, and this are all equal. So what can you do when you have something that's the same in every term of a mathematical expression that you learned in Algebra 1? Well, I'm going to say, I'll tell you what, I'll show the step. We know that I1 is equal to the total current. I1 equals the total current. I2 equals the total current. Well, now I've got the total currents in each term. I'm going to divide by it, and it cancels out. And we get the expression that we actually derived this in the lab the other day, yesterday, I think. The total current, the total resistance is just equal to R1 plus R2. Okay? And if I have more than two resistors in series, I would just keep adding. If I had an R3, I would just add it plus ... plus whatever. We'll call that n. But actually, for the problems we're going to do, this is good enough right here. Just add the two resistors that are in series together. So what do we know about resistors in series? To summarize, we know that the current is the same. I1 equals I2 equals the total current. Okay, at least in this one. We know that the voltages add up. V1 plus V2 equals the total voltage. And we know that the total resistance is equal to R1 plus R2. So this is basically everything you need to know for resistors in series. Okay, now we're going to get to the resistors in parallel, and it's a little more complicated. But it's going to make sense with what we just saw in the lab. So let's take a battery like this. Here's our total voltage delivered by the battery. Here's R1. And here's R2. And I could put on R3 and R4, whatever, in parallel. Now these are in parallel. Resistors in parallel, what do they, how can you tell if two resistors are in parallel? Well, the current splits up. I can either go through this resistor or this resistor to get the same voltage drop. Resistors in parallel have the same voltage. Right? You gain voltage across the battery, you lose that voltage when you go across the resistor. So for these guys, these two resistors, the total voltage is equal to V1. That is, if you know what the voltage of the battery is, you also know what the voltage across R1 is. But that's going to be the same voltage across R2. So the voltages are the same. When the resistors were in series, it was the current that was the same. But now, instead of the current, it's the voltages that are the same. That's going to be important. But here's the thing, and this makes total sense. What I'm about to do, it really does make sense. If you've got current flowing through this, we'll call this I sub t, the total current delivered by the battery to the whole circuit. Well, what happens right here? What happens right here? The current does what? It what? Yeah, well, it's going to go through both branches, right? Some of the current's going to go this way, and some of the current's going to go this way. Does that make sense? It's going to split up. It's like water moving through a hose, and you have a T in it. Let's say you have a hose like this, and you've got water flowing through it, and then it splits into two different directions. So some of the water will go up this way and some of the water will go this way. That's all that this is a junction. It's where the current splits up. Well, this is the current that goes through the first resistor, so guess what I'm going to call that? I1. And this is the current that's going to go through the second resistor, so guess what I'm going to call it? I2. Now, what's the relationship between the total current and the current going through the first and second resistors? Any ideas? Well, let's say I have 5 amps going through here. Let's say IT, or the total current, is equal to 5 amps. Now that's 5 coulombs of charge moving through the wire every second. Now let's say you measure this, and let's say you measure this being 3 amps. Oh, I2 is 3 amps. What do you think I1 is going to be? Why? That's correct. 2 amps is correct. Why do you think it's 2 amps?
3 plus 2 equals 5.
Exactly. Because you can't lose, because 3 plus 2 equals 5. The amount of current that goes into this junction has to be equal to the current that comes out of the junction. Doesn't that make sense? I mean, if you have water in a hose, if you have 5 gallons per second moving through this hose and 3 gallons per second going through this one, well, you better have 2 gallons per second going through the other ones. Otherwise, you got water leaking out somewhere. Okay? You got a leak in your hose. Well, if 3 plus 2 didn't equal 5, you know, if the current in didn't equal the current out, I don't know what's happening. You can't make current appear from nowhere or disappear from the universe. You have to account for it. So it makes total sense to say this. The total current is going to be equal to the current through the first resistor plus the current through the second resistor that are in parallel with each other. All right? Make sense? Okay, now we're going to get to the tricky part. Well, we have Ohm's law. V equals IR. This is true for the whole circuit, and it's true for each individual resistor. So, I'm going to solve this for I. The current is equal to the voltage divided by the resistance. This is true for the whole circuit, and it's true for each individual resistor. So now I'm going to substitute V over R for each one of these currents. So for the total current, that's going to be the total voltage divided by the total resistance of the circuit. And that's what I want. I want to know what is going to be the total resistance of the circuit based on the resistance of these two guys. Well, I1 is going to be V1 over R1 plus V2 over R2. Now, by the way, I'm showing this, I'm deriving an expression here. You will not have to memorize this derivation, but I'm just showing you that this, I'm not just pulling this out of thin air. I'm actually deriving it. Now, what's true about the total voltage and V1 and V2? They're all the same. So I can cancel them out. If the same thing's in each term, I can cancel it out. Or what I can do is multiply both sides of the expression by 1 over V, and that cancels this, this, and this, and I get 1 over the total resistance is equal to 1 over R1 plus 1 over R2. And in fact, this quite often electrical textbooks, you know, if you're going to be an electrician, you're going to learn this, and they'll just leave the expression like this. I don't like leaving it like this because what are you trying to find? What's the total resistance of the circuit? That's what I want to know. So I'm going to take the reciprocal of both sides. I'm going to say RT, that's the reciprocal of this, is equal to, now you can't just reciprocate these and get R1 plus R2. Won't work. You have to reciprocate the whole bloody thing. 1 over R1 plus 1 over R2. And this is the expression for finding the total resistance of a bunch of resistors in parallel. Right here. And it's not as hard as it looks, especially if you do it on a calculator. You know that 1 over x button on your calculator, the reciprocal button, you'll have to use that. Now, let's take a look at the circuit that we just did in the lab. Here was the lab we did, and you had a R1 was 10 ohms, and R2 was 10 ohms. Right? They were identical resistors, what we did in the lab. So what's the total resistance of this circuit? Are you writing this down? Okay, you should be taking notes, writing all this down. The total resistance is going to be 1 over R1. Well, that's 1 over 10 ohms plus 1 over 10 ohms. Now you can get a calculator out and do this, but you don't need to because this is a very easy one to do. The total resistance is equal to, well, let's combine these. 1 over, what's 1/10 plus 1/10? 2/10. 2 over 10 ohms. Now this is a compound fraction, so I'm going to reciprocate. I'm going to and multiply 1 times 10 over 2. That's going to be 10 ohms over 2. What is 10 divided by 2? 5 ohms. And that's my answer. And that's pretty close to what we got, wasn't it? For most of the groups, anyway. Got about 5 ohms, 4.8 ohms, pretty close to 5. Okay. So, to summarize, what do you need to know about resistors in parallel? I'll squeeze it in over here. Well, resistors in parallel have the same voltage. That is V1 equals V2 equals V3 if you have 3 resistors. Their currents add. That is, the total current is equal to I1 plus I2 plus whatever. We're not going to go beyond I2. We're not going to have an I3 or V3. And the total resistance is equal to 1 over R1 plus 1 over R2. And this is usually what students have the most trouble with, is calculating this, using your calculator correctly and all that. So, resistors in series, the current is the same, but the voltages add up to the total voltage and the resistances add. So that's pretty easy. But resistors in parallel, they have the same voltage, but their currents add up to the total current, and therefore, so you're getting more current for the same voltage in your circuit, which means your overall resistance is less. This right here, when you actually do this, you will always get a number smaller than your smallest resistor. Your resistance, your total resistance will always be less than the smallest resistor that's in parallel. That's one way to check your work. If you get an answer that's bigger than one of your resistors, you know that you've done it incorrectly, so you can go back and fix it. So let's do a couple of examples. Okay, so I'll call this example 1. Just put it right there. Let's say this is 12 volts, 3 ohms, And 6 ohms. So this is what's given. Fine. What is the total resistance? What is the total current? What is V1? And what is V2? So this is the kind of problems I'm going to give you in just a few minutes for these two in series. Well, let's solve. And I try to put these in an order that kind of makes sense. Okay, but whatever. The total resistance, well, first of all, I have to ask myself, are these resistors in series or in parallel? They're in series. And how do you know they're in series? Yep, one path through both of them. There's no branching. And we know that the total resistance for resistors in series is just R1 plus R2. That's going to be equal to 3 ohms. Well, we'll call this R1 and this R2. Plus 6 ohms, 9 ohms equals the total resistance. Got it. Put a little check up there so you know you got it. Now what's the total resistance? Well, I know what the voltage is. I know what the total resistance is. I can figure out what the total current is. That is, we'll start with Ohm's Law. The total voltage equals the total current times the total resistance. V equals IR, Ohm's Law. And remember, you can apply this to the total circuit, and you can apply it to each individual resistor, which we're going to do in a second. Well, this says, okay, I sub t is equal to V sub t over R sub t. So the total voltage is 12 volts. The total resistance is 9 ohms. So what is 12 divided by 9? Well, that's 4 divided by 3, which is 1 1/3. Pay attention, stay with me. Or 1.33 amps. That's the total current. Got it. Now, what's the voltage through 1? Well, V1 equals I1 times R1. And I know what I1 is, because what's true about the current? I know that I1 equals I2 equals the total current, because this is a series circuit. And so now you can just say, oh, okay, that's 1.33 amps times 3 ohms. And what do you get? 4? 1.1 1/3 times 3 is 4, I do believe. For what? Well, what is an ohm? An ohm is a volt per amp. So the amps cancel, leaving volts. V is measured in volts, 4 volts. Now, there's a couple ways now of getting what V2 is. How can I figure out what the second voltage should be? Well, what have I got? I got a 12 volt increase, so what do I need? A total of 12 volts dropped. Well, what do I got here? I got 4 volts dropped, so what do I need from here to here? 8 volts. So V2 should be 8 volts. Well, let's check. Though we can still do Ohm's law. So same current, 1.33 amps, but now we have 6. And 6 times 1.33, or 6 times 1 1/3 is indeed 8 volts. If you do the math. And then you can check, did I do this right? Yes, because V1 plus V2 should equal the total voltage. 4 volts plus 8 volts equals 12 volts. I did it right. Okay. Example 2. Same resistors, but now we're going to hook them up in parallel. Here's 12 volts. R1 is 3 ohms. Hope I didn't do this in the worksheet. Oh well, I did. It's okay. So R2 is equal to 6 ohms. This is what's given. And what do I want to find? Well, I want to know what is, in no particular order, what is I1, what is I2, what is the total current, what's the total resistance of the circuit. Yeah, that's good enough. We'll just do those things. So, first of all, these resistors are in parallel. Why? How can you tell by looking at them that they're in parallel?
They have 2 different paths.
Well, there is two different paths. That's one thing. See, right here, there's a junction, so the electricity can go from here. Some of it's going to go this way, and some of it's going to go, through this one. That's true. What else, though? Yeah, they have the same something. What do they have the same?
Voltage.
They have the same voltage. And that's why when we hook up the Christmas tree lights, right, they all burn with the same brightness when you hook them up in parallel, because they have the same voltage. Now, what is I1? Well, we can start off V1 equals I1R1. So I1 is equal to V1 over R1. And that's going to be 12 volts. Now, okay, do you see that V1 is 12 volts? You have to see that just by looking at it. It's in parallel, so they have the same voltage. So, okay, what is V1? V1 is just going to be the total voltage. So that's going to be 12 volts. And then what is R1? 3 ohms. So what is 12 divided by 3? 4. What is a volt divided by a volt per amp? It's an amp. So I1 equals 4 amps. Now, what is I2? We can do the same thing. I2 equals V2 over R2, just by solving Ohm's law for current. And this is going to be, 12 volts divided by R2, which is 6 ohms. Now this is a bigger resistor, isn't it? So a bigger resistor for the same voltage drop is going to have less current. 12 divided by 6 is 2 amps. Notice that I2, because it has twice the resistance, it has half the current flowing through it as I1 does. That makes sense. Stay with me. What is the total current? Well, what is the total current? How much current is being delivered by the battery to the circuit?
6 amps.
What's that?
6 amps.
6 amps, yes. Because the total current, look, I got 4 amps going this way. I've got 2 amps going this way. If I got 4 and 2 amps coming out, I better have 6 amps going in. And then it says, what is the total resistance? 2 ways to do it. I'm going to do it both ways. I can use Ohm's Law. Total resistance is equal to the total voltage over the total current. Total voltage is 12 volts. Total current turns out to be 6 amps. 12 divided by 2 is 2 ohms. That's my total resistance. So look, I got 3 ohms here and 6 ohms here, but together they result in having only 2 ohms of resistance. And remember I told you that when you have resistors in parallel, your total resistance will be less than the smallest one. What's the smallest one here? 3. So by adding another resistor, all we're doing is allowing more current to flow for the same voltage. So we're lowering the resistance from 3 ohms to 2 ohms. Makes sense? Now we can also do this. 1 over R1 plus 1 over R2. That's our equation for resistors in parallel. Yes?
Both of those work for total resistance.
Yes. Yeah, you'll see that we're going to get the same answer. Watch. 1 over R1. What is R1? 3 ohms. Plus R2 is 1 over 6 ohms. Now you can use a calculator to do this. And by the way, if you get really kind of difficult or decimal resistances or something, just use your calculator. But these are so easy, you don't need a calculator. 1 over, I need a common denominator if I'm going to add a fraction. So this is going to be 2 over 6 ohms. Just going to double the numerator and denominator. Plus 1 over 6 ohms. So that's going to be 1 over, well, what is 2 6 plus 1 6 is 3 over 6 ohms. Reciprocate and multiply, you get 6 ohms over 3, 2 ohms, which is what we got by using Ohm's Law. Okay. You don't have to do it both ways on the homework problems. So here's what I've done. I've done 2 problems for you. Example 1 is resistors strictly in series, asking about their resistances, total resistance, current, voltages. And then here with resistors in parallel, what are the currents? What's the total current? What's the total resistance? Okay. So you're going to have problems. I think on the problems I give you, there are actually 3 resistors. So I don't know. We'll see. So use these 2 examples to help you get for the first 3 problems. The other problems are more complicated, and I'll work an example problem for that when you guys are ready for it. That is all.